All right, so this is Unit 7, Building Block 2. And again, what's in this notes packet that I just handed out that you got is what's going to be on our next test. It's going to cover Building Blocks 2 and 3, so don't lose that notes packet. All right, so we're starting off with talking about some terms that look familiar and a term that probably won't look familiar. Zeros, undefined, and indeterminates. Okay, I think indeterminate may be a new term for you, but you should recognize zero and undefined. So we're going to start with just a little warm up. I want y'all to take a minute and try to solve for x for these three equations. Okay, so solve for x for these three equations. I'll give y'all, I don't know, 30 seconds, a minute to try that. See if you can solve for x. All right, for 2x equals 0, how would I solve for x? Okay, divide out the 2, and I get what? What do I get? 0. 0 divided by 2 is 0. Okay, cool. So this has one solution, okay, of x equals 0. Okay, what about this one? When you tried to solve for x, what did you try to do? Divide by 0. And what happens? Yeah, you cannot divide by 0, can you? Okay, so this one has 0 solutions. Okay, which means x is undefined. Okay, I'm make a couple little side notes here. Okay, you cannot divide by 0. This is undefined because there are no values of x to make the equation true. Okay, I'll put a little side note for what we said over here as well. Okay, the only value of x to make this equation true I don't really need quotes after that. Okay, is the x equals 0. Okay, so x equals 0 is the only value of x to make the equation true. Okay, here x is undefined because there are no values of x to make this equation true. Okay, what about here? If I try the same thing, if I try to do divided by 0, what do you think? Has anybody seen that before? 0 over 0? Okay, this is what I said would probably look new to you. This is what's called indeterminate. Okay, so in this case, 0 over 0, x is not undefined. It's not 0. It is indeterminate. Okay, what that means is there are an infinite number of solutions to make the equation true. Okay, and I'll put this aside because I said there's one solution here, there's no solutions here, there is infinite solutions here. And would that make sense? If I plugged in a 1, is 0 times 1 0? What if I plugged in a 2? Is 0 times 2 0? So you could plug in infinitely many numbers and this would still be true, right? So that's why this is an indeterminate. It's not undefined. It doesn't mean it doesn't exist. It's indeterminate. There's an infinite number of solutions. Okay, there are no solutions. Okay, X is undefined. Okay, feel okay about those three terms? Okay, 0, undefined, indeterminate. Okay. So when we look at rational functions, okay, rational functions have a numerator and a denominator. Okay, rational functions, the parent functions, the y equals 1 over x that we've been working with. So if you have y equals some numerator over some denominator, okay, this will be 0 when the numerator is equal to 0. Okay, it will be undefined when the denominator is equal to 0, and it will be indeterminate when both equal 0. You can write numerator and denominator. I'm just going to write the word both. Save me some writing. Okay, and you can see that in what we did up here. This had a numerator of 0. So we got 0. The solution was 0. This one had a denominator of 0, so it was undefined. And this had both. Numerator and denominator were 0, so it was indeterminate. All right, so we're going to check out some examples of rational functions. So we've got f of x equals 9x plus 30 over 16x minus 44, and we are asked to determine the values of x that make it undefined. Well, we literally just got through saying undefined means what's going to be 0. Go back to what we just filled in. To make it undefined, what's going to be 0? The denominator. So to solve, I'm going to set the denominator equal to 0 and solve for x. Okay, so if I'm going to solve this for x, I would add the 44 over. What you do to one side, you do to the other. Okay, and then I would divide out the coefficient. Okay, and then reduce. 44 over 16, that will reduce definitely by 4s. That would be 11 over 4. So x equals 11 over 4. That is where this function is undefined. So I'm going to write that out. F of x is undefined at x equals 11/4. Okay, and we're going to get in a minute into what does that mean for the function? What does that mean for the graph? Okay, but let's try this one first. Okay, so new function, g of x, negative 2x squared minus 4x over 4x plus 8. What values of x will make this indeterminate? Okay, so to be indeterminate, what has to happen? Both the numerator and the denominator have to equal 0. So I'm going to set both equal to 0 and solve separately. So I'm going to set the numerator equal to 0. And then I'm going to set the denominator equal to 0. I'm going to solve both of these, and I'm going to figure out, is there an x value that is the solution to both of those? Okay, so that would be add the 4x. Well, actually, here I would factor to solve this one. What could I factor out of here? Negative to what? X, right? They both have x. If I factor out negative 2x, what does that leave me with? Say that again. Okay, so for the first term, it's no longer going to be squared because I factored out one of the x's, so I'll just be left with x. Okay, so remember when you are factoring, okay, if you need to write this, write this. When you are factoring, you are literally dividing out that term. So negative 2 divided by negative 2, that's a 1. X squared divided by x, that's just x, right? Okay, negative 4x, if I factor out a negative 2x, so I'm dividing. So that's going to become plus, right? Negative divided by negative. Okay, and then the x's reduce. So 4 over 2, that's just a 2, right? So the whole point in factoring is to separate those x terms. So now you can split and solve. So you can say, okay, negative 2x equal to 0, x plus 2 equal to 0. Because if either one of these equals 0, the whole thing equals 0, right? Okay, so that's what we're doing. We're split and solve. So this one would end up being negative 2. And this would just end up being 0, wouldn't it? 0, I divide the negative 2 over. 0 divided by a number is 0. Okay, so I've got two solutions for this numerator. So now I need to solve the denominator. Okay, so I'm going to subtract the 8 over. Then divide out the coefficient. Okay, so is there a solution that makes both the numerator and the denominator 0? This one right here. Okay, so x equals negative 2 is where g of x is indeterminate. Feel okay about this so far? So you have to figure out, okay, are they asking for where it's 0, undefined, or indeterminate to determine should I be setting my numerator or my denominator equal to 0 to solve? Okay, so you have to be able to figure out where is the function 0, where's the function undefined, where's the function indeterminate. So what does that mean when the function is 0, undefined, or indeterminate? So some important ideas we want to write down. When a function is undefined, okay, that means that there will be a vertical asymptote. At that point, okay? So that's like this example we did right here. And we said this f of x is undefined at x equals 11/4. If we went to graph this, we would have a vertical asymptote at x equals 11/4. Okay? So when your function is undefined, there will be a vertical asymptote there. Okay? Now, there are some different types of discontinuities. Continuous means there's no break in the graph. Discontinuous means there's a break. So the types of discontinuity vary, okay? If it is a vertical asymptote, we're reading our graph left to right, and there's a vertical asymptote, that's definitely a break in our domain, right? A break in our graph. Okay, that type of discontinuity is called an infinite discontinuity. Okay, so for instance, those of you who are more visual, if I have a vertical asymptote somewhere in my graph, okay, and let's say my graph looks like this, as it approaches that discontinuity, that asymptote, it's infinite because this graph goes down forever here and up forever here along that asymptote, right? Okay, so maybe that'll help you remember that's called infinite because it goes up along that asymptote forever or down along that asymptote forever. Okay. Jared, come grab this. All right. Now, when a function is indeterminate, okay, this is what we're going to call a hole. There will be a hole in the graph. It will be a discontinuity. Okay, there will be a break in our domain as we read the graph left to right. Okay, but it's not going to be an asymptote. It's going to be a hole. It's just like if I, again, do a visual. So if I have some graph, some curve, it doesn't really matter what it looks like. But then I get to some point where there's a discontinuity there. It could be graphed something like this, and there's just going to be a hole there. And it would be graphed as an open circle like that. There's just a hole in the graph there. There's not an asymptote, it's just a hole. Okay, that type of discontinuity, it's a break in the domain, right? Okay, but it's not infinite. Okay, it's just at this single point. This is called a removable discontinuity. So an infinite discontinuity, that's your vertical asymptote. A removable discontinuity, that's just your hole. Okay, so some new vocab for you there. Good? Okay, so go ahead and flip over to the back side of that. And we are going to, for each of the following functions, determine the values of x that make the function undefined or indeterminate and state the domain using interval notation. We were practicing domain a ton before spring break. In Unit 6, tons of domain, right? And then Unit 7 in the calculator, we still did some domain practice. Okay, so lots of domain. We need to be able to give domain, and those vertical asymptotes or those holes, those discontinuities are going to help us determine that domain. Okay, those are the breaks in the function left to right. Now, if you're wondering, well, what about zeros? We know what zeros mean. What is a zero? What's another word for a zero? A solution or a... Remember, there were 4 terms that all meant the same thing. Zeros, solutions, roots, x-intercept. So when you find a zero, you found a solution. That's where the graph crosses the x-axis. That is not a discontinuity. Okay? That is where the graph crosses the x-axis. That's your x-intercept. Okay? So just to be clear, we're not going to need to find the solutions for the whole function unless we're ending up graphing it. Right now, we are just looking for domain. So all we need to know are the discontinuities. We just need to know where is it undefined, where is it indeterminate. All right, so for this first one, I'm going to set the numerator and the denominator equal to 0 and solve them. Now, there's kind of, you can consider it a shortcut. If you can factor, or if it's already factored and you can see common factors in your numerator and denominator, it's going to make your life a little simpler than having to actually write it out separately. But you can write it out separately if it's easier for you. Now, my denominator here, there's nothing to factor. It's just a linear function, right? Well, actually, there is a greatest common factor that's a constant that I could take out, which is a 3, right? But there's no x to factor out. But I'll go ahead and factor out the 3. So that would leave me with x plus 3, wouldn't it? And what about in my numerator? This is a quadratic. I can factor that quadratic form trinomial, okay, into 2 binomials. So the x squared would be x times x. Okay, what are the factors of negative 15 that add to negative 2? What would multiply to give me negative 15, but add to give me negative 2? Negative 5 and positive 3, good. Okay, now you have to be able to factor. If you wanted to do this separately, numerator, factor, solve, denominator, factor, if needed, solve. Okay, that's fine. But doing it this way gives you a nice visual. And what do you notice? This factor, x plus 3, that's in the numerator and the denominator, isn't it? So if we're talking about solving this, this would reduce, wouldn't it? When that happens, when you have a common factor in both the numerator and the denominator that reduces like this, that means there's a hole in your graph. There is an indeterminate. Okay? So that's just another way that you can see it besides actually solving all of the numerator and denominator, is by just putting this in factored form and seeing if there's a common factor. Okay, so if there's a common factor in the numerator and the denominator, there is a hole. Now what that means is there is a hole where x plus 3 equals 0. So what would x be? If I solved this for x, negative 3. So there's a hole where x equals negative 3, but since it's a specific point, I would actually like to know the coordinates. Because if you think back to what we, in this little visual I gave you, there's some specific point on the graph that there's a hole. Now, if it just, if you were looking at a multiple choice question and it just said, where's the hole? And it just says x equals, and all they care about is the x value, great, you're done. It's at x equals negative 3. Okay, but oftentimes you'll need the actual coordinates, the x and y of the hole. Okay, so you look at what's left in your equation. Okay, this is the new equation after that reduces, right? If I take that x value and I plug it back in to that x minus 5 over 3, I'm going to get the y value of the hole. So what's negative 3 minus 5? And that doesn't reduce, does it? So negative 8/3 is the y value. So there is a hole at negative 3, negative 8/3. That's the actual coordinates of the hole. Y'all follow? Okay. Now, is there somewhere else in this graph that's not a hole that would be a vertical asymptote? Is there an undefined location? Is there anything in any other x term in the denominator? No, right? So there are no vertical asymptotes, okay? And I'm going to abbreviate that VA. What that means is there was no undefined. There was an indeterminate, which is the whole, but there was no undefined, so there's no vertical asymptote. Now, I know it didn't ask for this, but I'm going to go ahead and put it, since we're talking about zeros, indeterminates, and undefined. There is a 0. What would make the numerator equal to 0? Because the numerator that's left is x minus 5, right? What would make that equal x minus 5 equal to 0? 5. So that's your x-intercept. Okay, so there was one x-intercept, no vertical asymptotes, no undefined, and one indeterminate location, which is a whole. So when we want to write our domain, what matters is the whole, the x value of the whole, and the x value of the vertical asymptote, which there is none. So those are the two things that matter for my domain. So my domain is going to go from negative infinity to negative 3. And then it's going to pick back up and go from negative 3 to positive infinity. You okay about that? Okay, we're going to try that with this one on the right. G of x here. All right. Nothing to factor out of the numerator, is there? 3 and 5, no GCF. Okay, so nothing to factor, so nothing's going to reduce and cancel out. So I know immediately, knowing that trick, knowing if something cancels out a common factor, there's going to be a whole. If nothing cancels out, because there's nothing to factor in the numerator to change this, there's not going to be any whole, okay? But I can still go ahead and set the numerator and denominator equal to 0 if that is a way that you prefer to do this. So I set the numerator equal to 0. Which I would have to subtract the 3. And then divide out the 5. Okay, so that's where the numerator equals 0. And then we could check the denominator separately. Okay, the denominator equal to 0. I'd have to subtract the 12. Divide by the 3. And get negative 4. Now those aren't the same, are they? So there's no indeterminate. So no wholes. Excuse me. Okay. Which one of these is the vertical asymptote, though? Is there a vertical asymptote when the numerator, where the numerator would equal 0, or where the denominator would equal 0? If you need to flip your notes back over, if you don't remember, you can go flip that over and check. Remember, we said where the numerator equals 0, that's your x-intercept. where your denominator equals 0, the denominator equal to 0, that's where you're undefined. That's where there's a vertical asymptote. So there's a vertical asymptote at x equals -4. There are no holes. So my domain, the only break in my domain is at -4. So it would be -infinity to -4 union -4 to infinity. And notice on both of these, I'm using parentheses at the break, at the discontinuity. So in this case, at the vertical asymptote, remember this is an infinite discontinuity, okay? And in this one over here, the discontinuity was the whole, but I still used parentheses. Make sure that you're doing that. You would only use brackets in your domain there when the point is included. And the whole point of this is these are discontinuities, the point's not included. So far, so good? All right. We'll give this one a shot. This needs to be factored. Okay, so when I go to if you want to do them separately, that's fine. I'll do the numerator. The numerator is easier to factor here because your A is understood 1. So you just have to ask yourself, where does, what are the factors of -20 that would add to 8? So what multiplies to -20 but adds to 8? I can tell you right now, it's got to multiply to a negative, so we've got to have one positive and one negative. And we know the larger number is going to have to be positive for it to add to a positive, right? So what are the numbers that would multiply to 20 but add, or in this case, subtract to 8? +10 and -2. Good. Now, the factoring with the denominator is a little tougher unless I can factor out that 3. That's going to make our lives easier, which in this case, I actually can. Okay, so if I'm going to do that first to make my life a little easier, that then just becomes x squared plus 3x minus 70. Okay, so now I've got the 3 out here. Now I can do the factoring with that understood 1 there. That's a little easier for me. Okay, so what are the factors of -70 that would add to 3? So it would multiply to -70. So again, it's got to be a positive and a negative. It would multiply to 70, but add to 3. Again, +10, this time with -7. So what do we notice? Do we have a common factor in top and bottom? This one, right? Okay, that's going to reduce. So that means that there's a hole at x equals what? What x value? If you need to actually come off to the side and write it, that's fine. X plus 10 is the factor. What would make that 0? X equals -10. You would subtract the 10 over. So there's a hole where x equals -10. Now, I really don't need the y value. I showed you how to find the y value. You would plug that -10 into what's left of the equation and solve this, but I don't need it because I'm just asking for domain. So really, I just need to know the x value. So I'll stop there for now. So there's a hole here, okay? But I also need to see, are there any vertical asymptotes? Because that is also going to break up my domain. So remember, vertical asymptotes happen where the denominator is 0. So is there another factor in the denominator? And yes, there is. Okay. So there's going to be a vertical asymptote. Okay. What x value would make this 0? positive 7, right? If you, again, if you need it off to the side to actually solve it, you're saying where is x minus 7 equal to 0? And you would add the 7 over and get positive 7. My pen all of a sudden is really laggy. Sorry about that. Okay, now there's this x minus 2 in the numerator. Does that affect my domain though? No, that's going to help me find my 0, my solution where it crosses the x-axis, but I don't need to know that for the purpose of my domain. So really, I've got what I need for my domain. My domain is going to go from negative infinity, and then what's further left, negative 10 or 7? Negative 10, so that's going to be the first break in the domain. And then it's going to go from negative 10 to 7, and that's the second break, the second discontinuity, and then from 7 to infinity. Okay, I'm going to go back here and do some color coding for y'all here. So these were common factors, so there was a hole. Okay, there was no denominator factor besides that, so there was no vertical asymptote. And in this one, excuse me, we had a vertical asymptote where the denominator would equal 0. Okay, but there was nothing to cancel, so there was no hole. So this one had a hole, this one had a vertical asymptote, this one had both. Let's try this last one. Okay, top cannot be factored, but the bottom can. First, I'm going to factor out the 2. Okay, and then I'm going to see if I can factor that trinomial. So what will multiply to negative 20 but add to negative 8? We did something very close to this right here. This was positive 8, negative 20. This one's negative 8, negative 20. Yeah, so it's still the 10 and the 2, but we switched the signs because we want it to come out to negative 8 when we add them. Okay, so this is my denominator. My numerator is the x plus 7. Are any of those the same? Is x minus 7 one of the denominator's factors? No, right? So what does that mean? No what? No holes. Okay, but I do see factors in the denominator that I need to solve. So what would make that 0? X is positive 10, and what would make this 0? Negative 2. So those are my vertical asymptotes, right? Y'all agree? So for my domain, there's no holes, but I have 2 vertical asymptotes. And which one is further left? Which one's lower? The smaller number? Negative 2. So that's the first discontinuity. And then it's going to go to 10. And then 10 to infinity. How do y'all feel about those? Okay. All right. So we have to know indeterminate, that's where there is a hole. That's where there's a common factor. Excuse me. A common factor in both the numerator and the denominator, like highlighted in green here. We have to know vertical asymptotes. Vertical asymptotes happen when the denominator equals 0. Okay, so these are the ones I was highlighting in blue, the ones that don't reduce. Okay, just what would make my denominator 0? So you set your denominator equal to 0 and solve, and this is what we get. And then the zeros are what would make the numerator 0. That's just your x-intercept. Okay, but it all goes back to what we started with, knowing that difference is 0 in the numerator, 0 in the denominator, or 0 in both. That's, you have to understand those differences. So lots of vocab you need to make sure you understand. 0, undefined, indeterminate, and what type of discontinuity those create. The undefined creates a vertical asymptote, which is called an infinite discontinuity, and the indeterminate creates a hole, which is a removable discontinuity. So we're going to be doing some practice in class tomorrow. We'll have an assignment to practice this. Excuse me. But you've got to know the vocab too. Besides knowing solving, setting numerators and denominators equal to 0, knowing factoring. So we might throw just some factoring practice mixed in there, because I know some people struggle with that. If you can't factor your numerator and denominator, you're not going to be able to answer some of the questions. All of them won't be as simple as these. This one had both of these that had an A value other than 1. You were able to factor out, and that won't always be the case. So you may need to go back to look at our factoring notes back from way back when we did some factoring practice. We talked about the different methods. You could do box method, grouping, slide divide bottoms up, guess and check. Okay, so there were some different methods for factoring quadratics that you may need to review. I'll probably throw some of that in there for the practice tomorrow. Is just practice with factoring. Any questions? Okay, so the bell's about to ring, so we'll stop this here and we will do practice tomorrow. And I'll post these completed notes in this video online.